for our next learning objective, you may notice there's another different number there. So again, it just means we've kind of moved on to a new topic that uses some new material, so it's not directly related to the last learning objective. I've been still going to build on all the sine and cosine and all the trigonometry stuff that we've been doing since spring break. All right, so we're going to start looking at identities. All right, so an identity is something that's always true. And we've actually looked at a few identities already related to our trigonometric functions. All right, really early on, we were talking about sine and cosine. We actually figured this out. You may not remember it, but this is a fact that's always true. If I take the sine of some angle and then square it, and add the cosine of some angle and square it, I get 1. All right, so sine squared plus cosine squared always equals 1. You can always replace this left-hand side with just a 1. And that kind of came from the Pythagorean theorem and some other things. All right, but in this learning objective, we're going to look at some new identities. All right, so it's going to look a little scary at first, all right, but let's just kind of explain what's going on. So these are called the sum and difference identities. So sum means you're adding things. Difference means you're subtracting things. All right, so if I have two different angles, so A and B are angles. They could also be alphas and betas to make kind of more obvious that they're angles. But if I know the sine and cosine of these smaller angles, alpha and beta, I can find the sine and cosine if I add those two angles together. And what would that look like? If I had this angle A, I kind of start there and then do the angle B. And that big angle together, which is the sum of the two, would be A plus B. All right, so now I can find its sine based on the sine of A and B. Same thing as if I subtract them, or same thing for cosine. All right, these formulas are not something you have to memorize. I'm not going to expect you to kind of instantly write down the formula for sine of A plus B. But you want to make sure you kind of have these in a place where you can access them easily, because once we get to later learning objectives, they might kind of pop up in random places. Again, you don't need to know the formula off the top of your head, but you need to know that if something like this comes up, that you know it's equal to some formula, and then you can go and find that. All right, on the exam, you'll have access to all these formulas and everything as well. All right, so let's see how this is going to work. All right, so we're going to find the value of sine of alpha plus beta if sine of alpha is 3/5 and sine of beta is 5/13. All right, so all we have to do at the start is rewrite that formula. And that's going to be sine of the first angle times cosine of the second angle. So I'm just rewriting that thing from the last side, plus cosine of the first angle, sine of the second angle. All right, so there's two things we can always put in here. Sine of alpha we know is 3/5. We don't know anything about these cosines yet. Sine of beta is 5/13. So how do we figure out cosine if we know sine? We did this in our first trig quiz. If sine is 3/5, I can make this right triangle where the opposite side is 3 and the hypotenuse is 5. Then we can use the Pythagorean theorem. This 3, 4, 5 comes up a lot. So if you see the 3 and the 5, this side that's missing is 4. And then the cosine of that same angle is the adjacent over hypotenuse. So now we know the cosine of alpha is 4/5. And put that there. We have to do the same thing one more time for 5/13. And that's our beta angle. Again, opposite and hypotenuse. And this is the kind of other one I use a lot when I want to use nice whole numbers, is the 5, 12, 13. All right, so if you do the Pythagorean theorem, you end up figuring out that that missing side is 12. And you figure out that cosine of beta is adjacent over hypotenuse is 12/13. And now it's just multiplying some things and simplifying. So 3/5 times 12/13. The 3 times 12 is going to give me 36. 5 times 13 is 65. 4 times 5 is 20. Again, 5 times 13 is 65. And luckily, these already have a common denominator, so I can just add them together and get 56/65. So if I know the sine of these two different angles, I can figure out the sine of if I added those two angles together. All right, and that's how we do it. We just use the formula that was on the previous slide, and we have to do a little bit of extra work because we're not given the cosine values, but we can always find those using SOHCAHTOA to our advantage. All right, SOHCAHTOA and the Pythagorean theorem. All right, so this is the new formula for if we're adding two angles together. All right, so in this case, you're going to find cosine of alpha plus beta if you have these two sine values. Again, be careful, you're going to use a slightly different formula because you're using the cosine one instead of the sine one. All right, so make sure you look at those formulas and use the correct one. And here's the final answer. So the first thing you have to do is figure out that if sine is 4 over 5, cosine's 3 over 5. So that's kind of the reverse of the last problem. If sine is 12 over 13, cosine's 5 over 13. So again, kind of the flip of the last problem. I put it into the kind of formula that was on that formula slide, and then just multiply and subtract your fractions. All right, so you can see once you have this formula, kind of just plugging and chugging, plug everything in the correct place, and then get your final answer. All right, here's where it's actually going to be the most useful. We're going to find the value of sine of 15 degrees. All right, this is something we could always do using a calculator. We just plug in sine of 15. That'll give us some kind of decimal approximation. But can we find the exact value with our square roots and things? So the goal here is if we can write the angle we care about, 15 degrees, as the sum or difference of those angles we do know. And if you think about that picture that we use a lot for the unit circle, those angles, those nice angles are these 5 angles. So if I can use those 5 angles in some way to either add them or subtract them to get 15, then this is going to help me. So the sine of 15, all right, there's actually multiple ways you can do that using these angles. I'm going to say it's the 45 degree angle minus 30, because 45 minus 30 is 15. But I just rewrote this one angle as the difference of two angles. And now it's just like the previous examples. I have sine with a minus sign in the middle. I look at my formula that says I take the sine of the first angle times the cosine of the second angle. Then I subtract the cosine of the first angle, sine of the second angle. So exactly like we did in the last problem, except for now instead of alpha and beta, we have the actual numbers 45 and 30. And these values, all right, sine of these angles and cosine of these angles, all right, we can use our unit circle. We've done sine of 45, that's always the square root of 2 over 2. Cosine of 30 is the square root of 3 over 2. All right, cosine of 45 is the square root of 2 over 2. Sine of 30 is 1/2. All right, so they're all values from the unit circle, remembering that sine is our y values and cosine is our x values. When you multiply two square roots together, you can combine them into one single square root and just multiply those two numbers. So that becomes the square root of 6. That only works for multiplication. You can't do that with addition. But since we're multiplying these two things, I can combine them. 2 times 2 is 4. Square root of 2 times 1 is just the square root of 2 over 4. And again, we kind of luck out a bit. There's already a common denominator. I get the square root of 6 minus the square root of 2 all over that one common denominator, 4. And again, because there's a minus sign here, you can't combine these two square roots. You can do it with multiplication, but not with the minus sign. All right, so I just have to leave these as two separate answers, or not two separate answers, two separate square roots. And I get that one answer. So if you were to type this in the calculator and this exact fraction, the decimal approximations would be the same. All right, so your goal when you're kind of doing these types of problems on the practice is, can you write the angle that you want to find, in this case 15 degrees, using our special angles or some version of our special angles. For instance, I could use 150 as well because that's related to the 30-degree angle. All right, so any of those special angles you can create with these 5, all right, can you add or subtract them to get the angle that you actually care about? And you'll end up seeing all these answers look pretty similar because you get a lot of square root of 3s, a lot of square root of 2s, or you get a lot of answers that look like that red box. All right, so for your example to try, all right, same idea, but you're just doing cosine instead of sine. All right, so go ahead and try that example on your own. And here's the full solution. So again, in this case, I use that 15 degrees is 45 minus 30. All right, you could also use the fact that it's 60 minus 45. You'd end up getting the same answer. All right, but plug in the numbers you know, and just remember that you can combine these two square roots into a single value, and you get this final answer. Again, looks really similar to the last one. The only difference is you have a plus sign instead of a minus sign. All right, a lot of the answers are going to look similar to this. All right, so for your last one, if you know that 75 degrees is 135 minus 60, all right, find cosine of 75. So you know these are your two angles you're using. Use that formula for cosine with a subtraction sign in the middle, and then figure out which one of these values is correct.